You were away yesterday. Don't think I didn't notice. So here's where we left off. What we're going to ask now. So, Zach, we've said we know what the b does in our exponential graph. Bigger base gets steeper faster. Smaller fraction decays faster. What does the number in front do? For the parabola, you may recall the a either flipped it up if it was positive or flipped it down if it was negative, and it allowed you to modify the 1, 1, 2, 4, 3, the stretch. It made it fatter or skinnier. What does the letter a do for the exponential? So you're going to want your graphing calculators out. If you don't have a graphing calculator here, you're going to want to sheepishly fess up, and I'll try and loan you one. Anyone don't have theirs here? So swap me a phone, please. Ready? Open your graphing software. You need one, or you have one? Okay. Oh, screen's still frozen. Thank you, Mr. Dueck. Open your graphing software, and then zone in. Clear any graphs that you have there. Remember, that's the F2 delete. Guys, thank you. So get to here, delete any graphs. And what we're going to graph first of all is 3 to the x power. So make sure it does say y equals 3. There's my exponent button. And remember, x is below the red alpha button. Do not use this x here. That means something different. That's actually x as a function. You don't want that. You want x as a variable right there. Sorry? Help them out. There you go. Help them all out. And then how do you store the equation? Enter. We should make sure that our view windows are all the same. So view window is Shift F3. Shift F3. I want the standard view window, which is -10 by 10, -10 by, which is also F3. You guys are probably still there. Maybe not, but probably. I'll hit execute to store that, and then I'll hit draw. And ideally, we all have this. The older calculators will take a little longer. The newer calculators, it should be fairly instant. Is that okay? Okay. This is our standard exponential graph, where the number sitting right here in front is invisible. What number is sitting there technically in front? A little invisible 1. This is if a equals 1, because what we're asking is, what the heck does this do? Well, if a equals 1, you just ignore it, and you get your standard exponential graph. On the same screen now, let's graph this. So F6, by the way, G to T graph, back to the table. F6. And I'm going to graph 2 times 3 to the x. What's that going to do? Did it change the shape? Not really. It's still, Matt, looks like every exponential graph. And what does every exponential graph look like? So it still looks like that. Now, it looks a little steeper. What I'd like you to do, please, is hit the trace button. Now, the trace button is F1. If you hit F1, now I'm going to pause. Anybody not here? Because now I'll let you catch up. Mackenzie, you're there okay? Because you're still typing? Or are you there? Are you there? I need a yes or no. No. Okay, let me pause the video. How many graphs are there on my screen? 2. So when I hit trace, it's giving me the option. It's saying, which graph do you want me to trace over? Does all of yours right now say y1 equals blah, blah, blah? If you go down arrow, that lets you choose graph number 2. If you had 4 graphs, you'd be able to go down arrow 4 times, and then it'll get you back to the top of the list. Meanwhile, let's go down arrow again, get back to graph number 1. And what I'd like you to do is type 0. Hit the number 0. And I think this screen will come up. On the old machines, does it as well? You hit F1 trace, and then you type the number 0. Okay? Now, on the old machines, hang on. If you have an older machine, instead of hitting F1 trace, you're going to hit F5 for G-solve. And you should have that option. And then you're going to go arrow sideways, which is F6. You with me? With me, with me, with me? Everybody got this? So it says YCal, XCal, and that funky thing. What we want to do is a Y calculation. So if you hit F1 and you type 0. Oh, sorry. First you have to tell it which graph. So F1 and your screen says this. If you hit enter to execute to pick that graph, and now you get that screen. Okay? Type in, please, x equals 0. What does the first graph go through? It goes through 0, comma what? 0, comma 1. Okay? Newer calculators go down arrow. Older calculators, we're going to go G-solve, arrow sideways, Y calculation, and now we're going to go down arrow to pick the second graph. On the newer ones, when you went down arrow, does it show you Y2 equals? Does that come up automatically? I hope. On the older ones, once you have this showing up, hit enter to store it, and do x equals 0. And this is the whole point of this. Ready? This one goes through 0, comma what? We're going to write this down. This one has a y-intercept of 0, comma 1. This one has a y-intercept of 0, comma 2. Have you spotted the pattern? Can you make a prediction for what the y-intercept is going to be for y equals 5 times 3 to the x? Won't be 0, comma 3. Good guess, though.
0, comma 5.
Sorry?
0, comma 5.
What do you think the y-intercept is going to be for 0.5 times 3 to the x? In fact, you know what A tells you? The y-intercept. Because do you remember, what did I say was actually in front there? It was invisible. 1. A actually tells you what your y-intercept is going to be. If there's nothing there, there isn't nothing there. There's an invisible 1 there. It's going to go through 0, comma 1. But actually, it's always 0, comma A. It's 0, comma A. It says to sketch these on the grid. We're not going to do that. Instead, what we're going to do is just fill in this chart. What's the value of A here? 1. What's the value of A here in this second graph? 2. What's the value of A here? What's the value of A here? 0.5. What's the base? B, 3, 3, 3, and 3. The base changes how steep it gets. B changes how steep it is. But A, Grayson, tells you the y-intercept. It's going to go through 0, comma 1, 0, comma 2, 0, comma 5, 0, comma 0.5. In fact, if I want to generalize it, every exponential graph has a y-intercept of 0, comma A. That's the answer to part C. It says, what's the relationship between the value of A and the y-intercept? The y-intercept is going to be 0, comma A. What if A was negative 5? What would the y-intercept be? 0, comma, negative 5. Now, how the heck is that going to work? We'll talk about that in a second, but it'll work. D says, does this also work for decay graphs where your base is a fraction? Yes, it does. I'm not going to do a bunch of graphs because we got a shorter class today with the assembly. So here would be a good question. This is on the old Math 12 course. The first 16 questions were no calculator allowed. What you did is you came into the room and you had to put your calculators on the floor next to you, and you got part 1 of the exam, which was 16 questions, no calculator allowed. This was a classic no calculator questions. It says this: which of those could be a graph of y equals, or f of x equals, 5 times 4 to the x? And the key is, what's the y-intercept going to be? What, comma, what? I got to be fussy. What, comma, what? 0, comma, 5. So which one must be wrong? This is, you did these as a process of elimination. Which one of these has to be the wrong answer? Okay, so you cross that out. Could the second one be that graph? No, because it's a decay graph. It's getting smaller. This would only be true if that was a fraction right there. So that can't be right. Could the third one be right? What's wrong with the third one? Can't be that. The answer is none of the above. They would have, on the provincial, there was always 4 to pick from. The fourth one would have been the correct one. In fact, you know what? I can make a sketch of what it would look like. It would look like this. And I know it would go through what, comma, what right there. 0, comma, 5. Who needs a graphing calculator? I know. I know it. And so in the old Math 12 course, along with the parabola, we used to build up about 5 or 6 different graphs in our arsenal, and we learned a lot of those shortcut tricks that you learned with the parabola. We generalized them, and then we applied them to several different graphs. And that's why there was a non-graphing calculator section on the exam. All right. What if A is negative? What if, instead of having a positive number right here, what if I put a negative in front of everything? Hey. What did the negative do to the parabola? Flipped it. You know what would be really nice? It would be really nice if a negative flipped it. I wonder. Go back to your graphing calculator. Hit F6 to get back to this menu here. You might have to turn your calculator back on. I don't know. Instead of 3 to the x, negative. By the way, look up. Everybody look up. This is the negative. That's a subtraction. Don't put a subtraction where you mean a negative. 3 to the x. And then beneath that, let's graph negative 2 times 3 to the x. And it would sure be nice. It would sure be nice if a negative just flipped the graph. Does it? And in theory, you should get that. It did flip it. Vertically. By the way, the fancy term for this, we call this a vertical reflection about the x-axis. Okay? Now, anybody not get that? Now is the time to ask. Sorry? Oh, you got it? Just took a while. Yeah, you got one of the older ones. But by the way, those are about 7 years old. You can see just in 7 years how much the computer chip processing power has improved. And those were about $30 more than the newer ones. Anybody else not get that? I still see people typing. Mac, you there? Got it? Okay. So, hey, what does a negative do? Flips it vertically. Which means instead of, for example, looking at part C, what's the value of A here? What's in front of the 3 here? -1. What's in front of the 3 here? What's A? -2, -5, -0.5. What will the y-intercept be of that first graph? Spot the pattern. 0, -1. What will the y-intercept be of this graph? 0, -2. What will the y-intercept be of the next graph? 0, -5 and 0, -0.5. And the only way that you can have a negative y-intercept is if you flip the whole thing down. So, just to help you visualize, I'm going to go like this. Delete, delete. So here's positive 3 to the x. And here is negative, I'll pick a different base, 5 to the x. Do they look similar? But how are they different? What can you tell me about their domains? How far left does each of these go? Forever. It kind of looks like it's hitting the x-axis. Trust me, it's not if we zoom in. How far right? Forever. So, where A is positive or where A is negative, the domain is still all reals. What about the range? If A is positive, it's going to be everything above 0. But what if there's a negative in front of our graph? What's our range now? Not everything above 0. Instead, it's everything below. Yep. X-intercept, 0, A, 0, A. It's just that in the second case, A is going to be negative. No, that's wrong. X-intercept, Mr. Dueck. Right? I got carried away. No x-intercept. The y-intercept, Rachel, is going to be 0, A. Stop smirking at me, kiddo. I make mistakes once in a while. And 0, A. The asymptote, both of these do get closer and closer and closer and closer to 0 high. They get closer and closer to y equals 0, because that's how you write 0 high. Y is how high you are. They get closer and closer to that. In fact, really, Mac, everything's identical except for the flip. Which is, I mean, about as nice as we could hope for. E says, are there any differences at the basis of fraction? Nope, it still works. Through the page. So, the shapes of exponential functions depend on A and on B. So, if A is positive and B is bigger than 1, here's what we really mean. Y equals 3 times 5 to the x. There's an example where A is positive and B is bigger than 1. What's that going to look like? That, as Matt has pointed out. Oh, and it's going to go through 0, A. In my case, 0, 3. Okay. What if B was a fraction? Y equals 3 times 1/5 to the x. What would that look like? We'll do a little sketch. First of all, will it be above or below the x-axis? Is there a negative in front of it? It's going to be above. Is it a fractional base or a bigger than 1? So it's going to be above, and it's going to be a decay. It's going to look like this. And it's going to go through 0, A. In my particular example, 0, 3. I'm going to erase this just so I have room to write here. You don't need to on yours. What if a was a fraction? For example, what if a was what if a was not a fraction? Negative. How about negative 3 times 5 to the x? Well, that's going to be a graph that's going to be below the x-axis. It's going to be this graph. Don't write this down. Flipped. Flipped. It's going to look like this. Where it also goes through 0, comma a. What if we have a negative and a fraction? Well, normally a fraction would give me this, a decay graph. But what's the negative going to do, Mackenzie? Flip it. So you got to use your imagination a little bit here. I think like this, yes? Like that. I mean, if you blank out, you can always make up an example and actually graph it on your graphing calculator. But hopefully, Brianna, you're seeing there's some symmetry here. Not easy, but there's some nice symmetrical stuff at least here. So here's the summary. The y-intercept of any exponential graph is always 0, comma a. Oh, and if there is no number, it's 0, comma 1, because there is a number sitting there, an invisible 1. Mac, can you fill in the next one? There is blank x-intercept. What word goes there? So make the grammar proper. You don't say there is none x-intercept. You say there is, really? No? There's no x-intercept. Don't overcomplicate this, okay? The x-axis is what we call a horizontal asymptote. As an equation, it's y equals 0. The domain is all reals. The range, Ashley, depends. Depends on if a is positive or negative. By the way, the short way to write positive or negative is greater than 0 or less than 0, and that's what we're going to do, because it's easier than writing out the word positive. But you make a little mental note. If a is positive, it's everything above 0. If a is negative, it's everything below 0. The values of a and b determine whether the graph is increasing or decreasing. Over here on the left, do a little sketch like that, and just make a little note. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. We go counterclockwise. Counterclockwise is actually the correct direction in physics, it turns out. The universe moves counterclockwise, but when we first made clocks, we didn't realize that. We really should have had clocks go this way. It would have fit in a lot better with science-y stuff. So, I'm going to do an example sketch and then erase it. You guys don't need to write this down. But when A is positive and B is positive, look, when we have one of those, what does the graph do from quadrant 2 to quadrant 1? Gets bigger or gets smaller? Increases is the fancy word. What about if A is positive, still above, but the base is a fraction? Then it's going to look like that. What does the graph do from quadrant 2 to quadrant 1? Decreases. What about if A is negative? but the base is bigger than 1. Then what we're going to do, don't write this down, we're going to flip that, which means it's going to look like that. So what does it do from quadrant 3 to quadrant 4? Well, I'm not fond of this terminology because it's getting bigger negatively, and a bigger negative number is technically smaller, so you can say that it decreases, but it's getting further from the x-axis, and I kind of like to imagine that that's increasing. So what I'm going to do actually is just say, I'm not going to use a word there, I'm not going to use a word there, I'm going to say it nosedives down. And in these ones, where we're flipping this guy, it nosedives up. Looks like that. Oh, and B also affects the steepness. As B gets steeper, as B increases, and the curve gets steeper as B decreases if it's a fraction. I'm less concerned with you, Mac, understanding these words. I'm much more concerned if you can do the little sketch that I did over there. And it all comes from every exponential graph looks like this or like this, and then flip it vertically as necessary if there's a negative. What's your homework? You got, good, 10 minutes before the assembly. Am I about to give the assignment? No, right now. Number 1. Bad timing. Gotta wait. Number 1's the problem, Mr. Dueck. No. Number 2. No. Sure. 2 is good. 3. State the equation of the. Sure. 3 is good. Not wild about question 4, so I'm going to nuke that. 6 is good. 7 is good. I'm going to assign 8, and I'm prepared to talk all about number 8 next class, but I'm curious to see who can figure it out. Nah, 9, nah. I have to do number 10 because it has Mackenzie's name in it. Spelled wrong, but that's okay. Nah, I'll skip 10. 11 is good. 12 is good. 13, 14, and 15. Okay. Did you get the homework written down? Yeah? So I finished my lesson? Excellent. Now let me pause the video.